First of all, thank you for coming. Tonight, I want to cover the changes to the National Construction Code, which now allow mid-rise timber building. So, the sponsors tonight are Wood Solutions, who are the national they're the Forest Wood Products Association Marketing Division, the Tasmanian Timber Promotion Board, who give us some funds to provide support for timber use. So again, if you've got questions about timber and construction, then please don't hesitate to give us a call. Now, Wood Solutions then provide a range of different activities. And so they have events, tech guides, a large website. So they sponsor tutes, which either I give or others, and they have online tutorials as well. Now, one other thing that they're doing is, and that we've been working with them closely, is a thing called Wood Solutions Campus. Now, Wood Solutions Campus then is an online education platform where videos on particular topics are being prepared, videos are being prepared, loaded online inside an educational platform, which are then free for people to get access to. So we've done a block of courses and are still making a block of courses that are specifically targeted to people in the building supplies industry. So that's those who work in the sales sections, in hardware stores, in timber supply, in merchants. We have also then recently put 20 videos on this topic, on changes to the NCC, onto that site, and we're just waiting for the front pages to be changed before they're then accessible. And those will then also have CPD points attached to them. So at the moment, there's only AIA CPD available from them. There's about 2.5 points across the videos. But we hope to extend that through to QS and Institution of Engineers CPD as well in the near future. So if you please sign in, make sure your email address is on there, and as a result of that, we'll email you the address for the Wood Solutions Campus, plus a copy of the presentation from tonight as a PDF. Now, this is a cut down version of a much longer presentation. So if it looks a little bit disjointed, it's just I didn't build it from scratch. There are 180 slides and I cut that down more than half. The things we're going to cover is the overview of the changes, timber construction options, the NCC related changes for fire, some things to do with sound and acoustics, design for building services. We'll then take a break somewhere around there. There's tea, coffee, chocky bickies outside, and then we'll look at the key points for delivery of successful solutions. So the first part will be a little bit technical. The back end will actually deal with some design issues at the same time. There is a bit of repetition in it because there's just a couple of key points that need to be hammered in. I'm happy to take questions along the way, and if there's something I'm going to cover later, well then I'll just tell you that and we'll get to it when the time comes. So prior to this year, the timber construction systems in Australia are restricted to 3 stories for deemed to satisfy compliance. That's generally class 2 and 3 and 4. Now, it was 3 stories or 4 stories if the bottom floor was a car park and you had a concrete slab. Now, for the NRAS buildings, the student apartment buildings that we worked with and on the project team for the job in Launceston, it was a 3-story project with car parking underneath. So in that case, it's regarded as just being 3 stories because the bottom floor is effectively open or service spaces. And that was allowable then under the deemed to satisfy provisions, and anything bigger needed an alternative pathway. So when Forte built the Lend-Lease building in Melbourne, which was I think 8 to 9 stories, it had to use a performance-based solution. The new NCC amendments now allow deemed to satisfy provisions up to what is called a mid-rise building, and the limit's 25 metres effective height. So it applies to class 2, 3 and 5 building. So these are the old rules. So this is the table which set out the type of construction required. And so type A, of course, is the most stringent. Type B and C, and what's green there was allowed in wood, effectively under a deemed to satisfy provision. And all of that sort of construction was covered in 3 early wood solutions guides that detailed the things you needed to do to satisfy those performance requirements, or those requirements. The new system allows then, has established this mid-rise construction arrangement, and it then sets up a series of concessions which allow you to use different construction arrangements to get to that 8-storey, 25-metre mark. And that's covered in this new guide, Guide 37. So there's now actually a lot of these timber design guides. They're very useful. They cover a wide range of topics. If you're not logged in or don't have a registration on the Wood Solutions site, I encourage you to just log in and get one. It's all free, and download the guides that are relevant to you. They deal from everything from interior design, external finishing, fire separation, and different construction systems. And they're all pretty easy to use. So the new DTS provisions cover traditional lightweight framing options, plus what it calls massive timber systems, such as CLT, glulam, and LVL. And it consists then with the use of appropriate layers of fire-resistant plasterboard to make what it calls fire-protected timber, and then a compliant sprinkler system. So what it gives you then is a whole range of opportunities for class 2, 3 and 5 buildings and ways in which they can be constructed. So if we just look at some of the construction options that are available nationally. So we've got general framing systems, basically where we're taking single elements and then using them to either make a structural frame or a wall frame. We've got lightweight frames, heavy timber post and beam, post-tensioned. Now I've got a slide on each one of these. So portals, there's massive timber, which is panel walls or floor systems, and then we've got a range of modular systems. So if we look at some design approaches with class 2 and 3 buildings, they tend to be honeycomb style construction and honeycomb type structures with relatively close walls. We're not dealing with posts and open floor plates. And these can be constructed in several ways. Now, one way is to use basically lightweight construction up to about 6 stories. So this is what is an adaptation of a standard timber frame wall, where you've got 2 wall systems side by side, basically to give you the sound separation between apartments, but you're also using double studs. And using double studs because you've got the level of compression coming from the loads above, and a single stud won't do it. Now, you could try and buy a bigger bit, but no one makes them, generally. So everything's cut at a 35 or 45 size, and then you just double them up. Other approaches are to use lightweight above and massive timber below, so that on the floors where you have higher loads, as you move then to full systems, full massive timber systems, or you use the full massive timber all the way from base up. There's also then ways in which you can take a combination concrete and timber systems, whereby you've got concrete down on lower levels to do things like car parks and retail levels, and then you've got a concrete plinth and you put your timber frame directly above that. Now, there has been sufficient practice in multi-storey timber construction now in Europe and other places that a lot of the jointing systems that you need to get very high shear values in some of these panels have now been resolved, and they're actually available in the marketplace if you know the right people to ask. So I'm one of the right people to ask. I can't deliver any of them, but I can point you in the direction of people who can. So others is heavy timber post and beam using glulam or CLT. Now that's the Lend-Lease building, the Docklands Museum, Docklands Library. That was predominantly a glulam building with CLT floor plates and CLT shear walls in the centre. So you can see there from the basic structure, we've got shear walls there in the middle that are CLT floor plates between the glulam frames and large glulam columns. They all came as a package. And then we've got portal frame systems. If we look at other frame systems, if we look then at frame systems, we've got the lightweight timber systems. So this is effectively standard stud framing arrangements. And this was the traditional method in which you built up to 3 to 5 stories, which is an extension of house construction, but with lots of extra detailing. So this arrangement here is concrete floor, 4 stories up, and it was probably, I think that one's in Melbourne. You've got post and beam construction using LVL and glulam. Now these panels here and the ones in the shear walls there aren't CLT. They're actually large panels of glulam side by side. So you don't have the cross laminates, you only have the boards arranged vertically, and that then forms large flat beams or shear walls that you can use. Now these are projects in British Columbia. There's then post and pre-stressed LVL and glulam composite beam systems. Now this is put together as a system called X-Plan. It was funded jointly by Forest Wood Products Australia and a similar organisation in New Zealand. And effectively what it does is it takes large-scale timber elements like this, it then combines steel tendons in the system to allow you to build relatively flexible joints in the structure. And it was specifically designed, well, one of the reasons that drove its design was basically resistance to earthquake in New Zealand. So this project actually started prior to the big earthquake in Christchurch. Several of the buildings that have been built in Christchurch in the recovery effort there have used this system because they can sustain another earthquake and then just be tightened up again. So you use this approach where you incorporate the steel tendon in a box beam, like one of these, or you can expose it underneath, etc. It's an adaptation of actually quite an old technology, very common in Victorian buildings and other types of buildings over the ages, but here used in a much more sophisticated manner. Now the design software and detailing is all available through FWPA. They've just announced or released another whole series of guides on this system, if anybody's interested in it. Massive wood panel systems then include LVL, cross-laminated timber, and nail-laminated timber. So this is LVL, this is CLT. Someone snuck up to me last night during the break and said, "Greg, can you describe CLT to me?" So just in case there's similar persons in the audience, CLT is layers of wood that have been glued together so that the boards are on flat, like this, and alternate layers are, each other layer alternates in grain direction. So effectively, an analogy is it's thick plywood. The thing is though, is that now there's been enough experience with it so that sometimes the outside 2 layers are actually paired and both running in the same direction, because the outer layers are the ones doing most of the work. So if you've got to span a long distance, you actually want most of the grain running in that distance. So they're making panels that have 8 layers and and 10 layers with double layers on the outside running in one direction. So that's quite an established techniques now in Europe. There is a manufacturer setting up in Albury at the moment, and so they're supposed to be in production sometime around the end of February, March. The other system at the end is not actually CLT. It's just panels that have been either screwed together or glued together above board on their own, just one board after the other, and then used as shear walls. There's a whole range of prefabricated systems then that are being used. Now these ones are relatively domestic scale in that they're floor cassettes. Larger scale ones were used in a job in Parkville in Melbourne. Spans up to 12 metres. There is also a whole series of concrete timber composite systems that are now being used or being proposed. In some cases in Australia it's basically being proposed, in other places they're being used. So this is an old photograph of a system whereby joists were put down, plywood was put on the top, and then shears, actually just coach bolts, were put in at regular centres, and then a concrete topping was put on the top. So for this instance it was good, it gave better fire and sound protection between the two. The Europeans now, who are using much more wood in their construction, have now developed a range of different systems using new generation glues, where they're putting a saw cut through the top of the timber, like the top of the glulam beam. They're then inserting an expanding polyurethane glue into there with a punctured steel plate, which is particularly coated, etc., specifically designed then to take Rio, and they're then using that sort of much simpler system to create composite timber concrete constructions. So there are a range of different options that are available. And again, if people want to see photographs of any of these systems, then I'm quite happy to pass them on. There is then panelised elements. These are pretty simplified ones, which are just frames with simple services in them. But they scale up quite quickly, or there's full modular type systems. So this is one of the apartment modules that was made for the NRAS project in Launceston, finished in a factory, brought to site, plopped one on top of the other, finished off, and that's the building there with all of the modules in place, the roof on, just before it was clad. So we worked with James Morrison's office as part of this design team. So anyone who's got interested in this sort of construction system, we can provide some first-hand experience and details on this. So there is then a wide range of timber construction options that exist to use in multi-res. Now I don't think we actually did calculate exactly how high we could go with those modules, but I reckon we could have easily gone 3 to 5 stories before we had to reinforce the whole systems. So they were pretty robust little boxes. And there's significant efficiencies, speed and cost benefits by using some of these systems, especially as skill in using them develops. So if we look now at the NCC changes. So the NCC is the National Regulatory Framework for Construction in Australia. There's 2 volumes. Volume 1 deals with classes 2 to 9. Volume 2 deals with class 1. Class 1's effectively houses and cottages. So class 1, usually if there's a professional involved outside of a ground engineer, then it's basically you deal with volume 1. So with all mid-rise timber construction or mid-rise building, you're dealing with volume 1. There's 2 ways in which compliance can be shown. So the NCC is a performance-based code, which means there's parameters set that you need to comply with. there are two methods of doing that. The first is to use a deemed to satisfy solution. That's a cookbook approach that says if you follow the rules set out in the document, then that's deemed to satisfy the performance requirements. The other way then is a performance solution, also known as an alternative solution, which says we're going to do something different and we're going to show that we satisfy the performance requirements by calculation, modelling, etc. to the standard, to a level that satisfies at least the same, demonstrates at least similar performance to the performance requirements. Sorry, I got a bit tongue-tied there. Generally what happens is you'll have the deemed to satisfy provisions and someone will want to do something a little bit different. And so most of the building will comply with this and the extra bit then will be certified and dealt with. The thing is that deemed to satisfy solutions are much easier for everyone to use because all you need to do is you comply with the rules in the book and it's a tick. You don't have to get complicated or expensive fire engineering or other engineering done. So that's the section that's being covered then by the new Wood Solutions Guide. So the major changes as regards timber is concerned that are in the NCC, there's 6 major changes. The first is an inclusion in the definitions of what fire protected timber and massive timber are. So it's the first thing. The next is that there's a new specification A1.1 for fire protected timber, so that defines what they are and how they perform. Clause C1.13 gives you the concession that recognises timber construction systems as equivalent to other forms of construction. You'll then have a variation for type A construction, which is the most rigid of the 3 construction systems that are required in the NCC. There's another modifications then to type B construction, which is the second most stringent. And lastly, there's a specification that deals with cavity barriers. And that's something they're going to mention a lot tonight, cavity barriers, etc. So the key words that come out of the key concession that allows you to use timber in these types of buildings are these. So you've got fire protected timber, we've got class 2, 3 and 5 building, so that's all it's allowed for. We've got particular FRL requirements. We've got an effective height of no more than 25 metres. We've got to have a sprinkler system. Any installation installed has got to be non-combustible, and we need cavity barriers. So with fire protected timber, we're going to be using fire grade plasterboards to delay or prevent the ignition of any timber elements that are serving a structural function in the event the sprinkler system fails. So that if the sprinkler system fails, that the structure will still perform for the required period of time to let people get out. So it's a bib and braces approach. So the response will be similar then to non-combustible elements. Now I think it's worth reflecting that if you have a fire in a steel building, a concrete building and a timber building, then the consequences of all 3 should be identical if they're compliant structures. Is that everyone should get out, that's the first thing, safely. And the second is that at the end of the fire, the buildings are totaled. So the steel building's totaled, the timber building's totaled, and the concrete building's totaled. Because the scalding you get from most fires in a concrete building are going to see at least significant reconstruction of the building, and if it's in the bad spot, basically the demolition of the structure. So there is no difference in performance required by construction system. The consequences of each of a fire should be identical. So the lightweight timber construction then gives you timber frame, which is either 90, 120 or 140 by 35 or 45, depending upon the amount of load it's taken above. And then typically with 2 by 13mm fire-rated plasterboard on the walls and 2 by 16mm fire-grade plasterboard on the ceiling. So the ceiling has got to be thicker because that's where the heat's going to go. The walls are subject to less heat than the roof, and the floor there is no requirement for because the fire goes up and that's where the heat goes. The fire doesn't burn down. So in many of these buildings there'll be a fire. Given that it starts inside the room, the floor will be relatively undamaged. For massive timber, there's a couple of key requirements. The first is the system's got to be a minimum of 75mm thick. So any timber system you can then get solid 75mm thick is likely to pass. So that means glulam at 75, LVL at 75, if someone makes a 75 LVL, and also then CLT products. Now at the moment, the dominant maximum size of LVL in Australia is 65, 63, I think. But I suspect now that these have been released, there are plans to actually put a 75 on the market because it does open up a lot of opportunities for LVL in these forms of construction. Especially given how little glulam production capacity there is in Australia, especially for big sizes. Okay, so with them, you're looking at one layer of 16mm fire-grade plasterboard on the walls and ceilings. Now, I was asked last night a question about what happens if I want to see the system, and the answer is I have no idea. Whether a thick system plus one layer on one side will actually be adequate to satisfy the rules, or whether you actually need then to make that an alternative solution for at least that requirement. So the next major thing then is cavity barriers. So cavity barriers are there to prevent any gases, fire, etc. that does get into here from going up in between apartments and in through the floor spaces and into the apartments above. So it's to stop what's called the incipient spread of fire, which I'll deal with in a bit more detail in a minute. So the cavity barriers have effectively got to be between every sole occupancy unit. So they've got to be between the sole occupancy unit and the outside cladding, between one and the other on different levels, and between the sole occupancy units and the roof or any other open spaces. So basically, these are the key spots and the details available in the guide that will show you where the cavity barriers need to go. So here's the one between the floor-wall junction, and as James is correct, that space between one wall frame and another that the fire can potentially get up through without having to go through the timber has got to be blocked off. Here, between the two apartments where you've got the cavity and the external cavity, that's got to be blocked through. Here does, there does, because there is a fire protection requirement for across from here and into there, which those two layers of plasterboard are doing. Sometimes that's reduced down to one wall with plaster on either side from people who are tight and want to save the money on that. And they're similarly under here, above and below windows. Okay, so then the next major requirement then is non-combustible insulation, because there's a lot of insulation built into these systems, and it can be a nasty source of fuel. Okay, so we're going to go through each of these particular points again a couple of times. So if the building or building part is 2, 3 or 5, its effective height no more than 25 metres. It has fire protection timber, automatically sprinkler system, non-combustible insulation and cavity barriers if they're applicable, then it can meet the deemed to satisfy for mid-rise construction. Now, as soon as you move away from that and you want to go to a performance-based solution, then there is various alternative solutions set out in these guides, which will help guide how you get your alternative solution through. So if we look at some key terminology, is that key information. Now, in the back bit, we're going to do a little bit about what information you need as a professional then to give through to people. But the key things we're going to need to discuss, understand are fire resistance levels, resistance to incipient spread of fire, and the results of non-combustibility tests. So an FRL is a 3-numbered requirement which sets limits or requirements for structural adequacy, integrity and insulation. So you'll get a number like 60, 60, 60 or 60 dash dash or dash 30, not 30, 60. And what that means is that the first number is structural adequacy, which means that in a design fire, the element's taking a load, therefore it has to continue to take the load for the period of the design fire. So it's got to take all of the loads that it would be expected in a fire for 60 minutes or 90 minutes, whatever the figure is. Integrity is that it stops the passage of flame from one apartment to the other or one unit to the other for the required period of time. And insulation is that the temperature on the other side of the wall doesn't go up sufficiently to actually start a fire or cause an injury to someone on the other side of the wall. So that means is that if you've got a bed on this side and the bedroom on the other side apartment is burning, you should have the period of time set down in the BCA that you're still safe on the other side. Now, with all timber construction, FRLs are achieved generally by materials working in composite as a system. So you'll have either very, very thick timber, or you have timber and plywood, timber and particle board, or nail plate trusses and plywood, or some other form of, other forms of combination of sheet material and timber structure. Now, a resistance to incipient spread of fire is the relation to a fire protector covering that means the ability of a covering to insulate voids and interfaces to limit the temperature rise to a level that will not permit ignition of the timber and the rapid and general spread of fire through any concealed spaces. So it's that a fire in this side will not cause the timber on the other side to ignite or then allow things through and allow any of that structure to ignite. And there are specific requirements for it. There's also a non-combustibility test, which is important then for insulation and other things that you're using in the system. And effectively, the material's got to be tested to AS 1530.1 to show that it's non-combustible. Now, of course, these all become important when you're writing any specification for the system, is that the tests have to be called up and certificates to those tests have to be secured. So you may get this sort of nomenclature appearing in the guides and on documentation, so that the FRL of 90-90-90, that you've got a resistance to incipient spread of fire of 45, and it's non-combustible. So certificates may also include such abbreviated nomenclature to show what the system can do. So if we look at what's actually required under the NCC with class 2 and 3, the general requirements for FRLs are 90-90-90, that's 90-minute structural integrity and insulation, and a resistance to incipient spread of fire of 45 minutes. For massive timber, it's not the same FRL with a reduced resistance to incipient spread of fire. For class 5 buildings, it's 120s and 45, and again 120s and 30. Now, if it's concrete, it's exactly the same. So the FRLs are identical, depending upon, and are independent of material. So the system has to provide it. Okay, so sound requirements. is that there are particular requirements for sound separation throughout the building. Now that's for both airborne and impact sound via the floor and wall systems, so that those requirements exist for between adjoining SOUs, sole occupancy units, and between sole occupancy units in the common spaces, and between the SOUs and other building classifications. So we've got here, there are requirements there are requirements here, and there's also requirements at the top where you've got some store or other function or plant room that isn't an SOU. So the two things are airborne sound and impact sound. Airborne sound is me on the microphone, or the teenager next door with the speakers, or people talking, or loud music, whatever, in the adjoining rooms where the energy comes from the air into the wall system and then has to move through the wall system. But the major one is actually impact sound. And impact sound is the sound that you will get in structures of knocking, such as washing machines or dryers banging against the sides of cupboards, people putting plates down, pipes, hydraulics going through pipes, etc., can all generate impact sounds which will travel through a structure. Now, there's various requirements built into the NCC. Now, don't ask me to tell you what those ones mean. It's moved on well beyond me being able to translate some of this stuff. So what I will tell you, though, is that the requirement is 50, and you'll get it from a system. Now, this is the minimum system that you're going to need to get that level of performance. So you'll need at least stud, insulation, plasterboard both sides, and the plasterboard on one side mounted on a resilient mount on a batten. Now, the other is a double stud system, and a double stud system will give you a vastly superior performance to this one. Now, the thing is that if this was a blockwork wall, you'd still need to batten it out with this batten and put plasterboard on the inside, because blockwork on its own does not give you that rating. So you still need to plasterboard and batten off. The harder one is the floor systems, because the major sound there is impact sound, the sound of people walking. And in terms of building quality, impact sound, especially floor sound, is probably the most critical thing in people's assessment of having a quality building. So there has been a lot of work done on improving systems that give you good sound separation through the floor system, including things like adding concrete toppings, sand toppings, then to add mass to the system, and also to have more than one type of material, because one material, they'll absorb different sound frequencies. Okay, so if we're looking for design for building services, and Stuart brought this up earlier on, and it's a key part of design. Now, it's really quite critical that in the design, you try and work strategies in the way in which you're providing your services, whereby you minimise or just don't compromise the fire and sound separation systems. Is that you really only want it to occur with absolute necessity. You don't want to do it flippantly. So the way in which you then treat your planning so that your services can be put in, that they can be maintained without breaking down fire and sound separation barriers becomes quite critical. So the number of service penetrations through those systems should be minimised as much as possible. Now, ways in which that can be done, if you take this as your sole occupancy unit, here's your fire boundary layer, and you really don't want to puncture that this way at all. Again, you want to try and not puncture it this way also. So there's particular ways in which that can be done. One is to put false ceilings in, especially bulkheads over things like kitchens and service spaces, hallways, whereby you can get lights, downlights and other forms of services through. Where you put surface ducting in, where you actually use the floor void as the means of getting services from one location to another, because there's no fire separation between this layer and there. So you can come up through the floor easily. The other is that you then try and get your plumbing out the back, and you position your plumbing so that it's very close to a duct. Now that's one of the key bonuses of products like floor trusses or I-beams, because you can actually route out the I-beam to take your services before you put them into the floor. Or with nail plate trusses, like floor trusses like this, you can design all your flooring, all your servicing systems, and they'll actually accommodate that in the design of the trusses, and they'll come with those spaces already prepared. So that's a critical part of design. When you move outside of that from your apartments into the general lobby circulation areas, you're looking to create ducts, vertical risers and horizontal risers that then allow you to put your services in and maintain them, and then get your minimum amount of disturbance to your fire separation systems. So here we've got ducts through a service riser, where this could have plasterboard enclosure, and then still have fire-rated openings so you can get in there and maintain the things. You can run across the top and then punch this through in a hole that then you can fill with fire-rated blankets or pillows, or with fire collars. Then if you use inside your apartment, you're using drop-down ceilings and false walls, you can effectively put all your services, you want to put all your services through without breaking those layers through at all, or as little as possible. So part of it's a design approach, is that you always try to get your services on the inside walls, the non-load bearing walls, and bring things up through the floor, and that solves a lot of problems. Okay, so that disappears. All right, I think it's time for a cup of tea. There's a couple of key points then I want to run through for successful delivery of this sort of building. So if we look at we'll quickly go over the summary of the deemed to satisfy requirements, general fire design principles, roles and responsibilities, and some key points for each of the various construction stages, except the last two. So if we just look at the summary of controls, the building or the building part is a class 2, 3 and 5. It's got an effective height of no more than 25 metres. It's got a sprinkler system to spec E1.5. It's got fire protected timber. It's non-combustible insulation, and there's cavity barriers to that specification, or with massive timber construction that has no cavity barriers because there's no cavities. There's a number of critical layers of fire protection. The first is the automatic fire sprinklers. So that's actually the first one, is that's regarded as the key fire protection system throughout the building. The second is the use of fire-rated plasterboard to give you fire protection to the timber elements. You've then got the use of cavity barriers to prevent fire and smoke spread through the cavities. And lastly, there's the use of non-combustible insulation to minimise fire spread in the cavities if the fire does get in. So in roles and responsibilities, there's then a building procurement process, and the various roles and responsibilities through the procurement process then become important. If people are doing this in the first 2, 3, 4, 5 times, then people along the supply chain and not necessarily going to be experienced enough to know that you can leave out particular requirements and them get it right. So over-specification or being overly prescriptive initially is probably a very good approach. So at the beginning, then the roles and responsibilities of the design team needed to be clearly established for the design and documentation, assessment and certification, building construction, inspection during construction, commissioning and maintenance. There are various people who are involved in each of those stages. And in the bits we're going to do in a minute, we're going to cover these first four, but I'm not going to do the last two. So with design and documentation, we've got the project design team who become critical in the selection of systems that are deployed and in their detailing. So key issues include ensuring that all the fire protection elements are clearly documented in the system. So that's sprinklers, fire protective linings and claddings, cavity barriers, insulation, etc. That you've then got good evidence of suitability for all the product systems that are being specified. Now that becomes important, and that's why I've harped on some of the specifications, some of the standards, because that level of information needs to be collected, because it's going to be provided up the line, and it's also going to set the boundaries of what the builder is going to be held to do later on in the process. So looking at team responsibilities is then important. The next thing is the design team should engage with the key construction team representatives early. Now, the key construction team is obviously the builder, the timber structural systems prefabricator, assuming that there is one, and usually there is, and then service suppliers and lift suppliers. Now, it's quite common for some of these people to start to be put in as nominated subcontractors, but it's less likely for the others. And of course, with full tender systems, it's very difficult to know who the builder is. However, a lot of timber fabricators are actually used to consulting on projects, providing information, and then hoping they pick the job up. I mentioned last night my favourite local fabricator, who's Fred Boswell from EcoTruss, who's very, very active in the north in getting timber construction into buildings. There are similar people operating in the south, some with more or less expertise. So, but some of those people are very good at being able to then provide design and costing information that enables people to get efficient systems on the ground. And they generally do that before they're guaranteed the job, because they know that if they don't, the job will go to a steel job or a concrete job. And they don't want to see that. They want to see it as a timber job. If they don't get it this time, they might get it next time. And they want to build up good relationships with people. Now, that's very much the same with glulam manufacturers such as Hines and others, who actually often do quite a lot of work before the job comes in the door, or that it's secured for them. So with assessment and certification, the building surveyor's got to ensure that the design and documentation is complete, obviously, and that it complies with the regs. Now that's part of their normal role. This is also part of their normal role, ensuring that the performance solution is satisfactory. But this one will become particularly important if you're using an innovative system, because they're going to be looking to ensure that everything is covered. So as a designer, then it's in your interest to ensure that you've got all that evidence of compliance beforehand, and then you can provide that through to the certifier, because they may not have seen it before. And therefore you're lubricating the approvals process. And it will take some time for them to build up confidence in the various systems that you might want to employ. With building then, it's important that all on-site staff are suitably trained, knowledgeable and competent in relation to the mid-rise timber building requirements. Now, they're new requirements and therefore many builders will not know them. So that's an important point to consider, is that most will be competent with timber frame construction and with house construction and even some fiddly bits that they might have come across in a 2 to 3 story building, but they may not be competent with an 8-story one, and therefore the documentation and the briefing has got to be such that A, they know about it, and B, you can hold them to it. So all site constructors have explained to them and they demonstrate a clear understanding of the issues of fire protected timber construction. Now, Wood Solutions is providing some information to support this and etc., but it's all got to happen on the jobs as they go through, because as we know from, as most people will know, is that sure, you can put it in your documentation, it will go to the builder, and then the level of control that might be able to be exercised over the builder may not be at the level that you actually want to ensure that the innovative approaches are going to work. So it's something people have got to be cautious about. It's important that all systems be installed as per the manufacturer's recommendations, and that in itself is a bit of a challenge, especially with taller construction. Now, it often happens that because something goes to timber, it actually opens it up for a range of builders that may not normally have been considered for that type of project. Therefore, you've got people, they don't know about the other general constraints that may be that a builder who's used to these multi-story or the multi-million-dollar projects would be used to. And making sure that the tradespeople they know actually know what the manufacturer's recommendations are becomes important. So that proper process and quality practices are undertaken, and that on-site workers are diligent and report concerns in terms of non-compliance, especially in the early stages of systems being used. So that all on-site staff and contractors need to understand the fire-protected timber systems that are not the same as standard timber frame construction. And it does get quite dangerous. When my house was being renovated, I had to ensure that the roofer put the insulation in the right way around. And he abused me. He said, this is the way I've been doing it for 25 years. And I say, you've been doing it wrong for 25 years. Here's the manual. Now, those sorts of things will occur on all sorts of buildings. And when we're doing innovative construction, we need to make sure that those problems are avoided before they get built in and covered up. So that fire-rated linings are installed correctly and must not be breached. The cavity barriers must be installed at all points required, and that the cavity barrier installers must ensure that they're installed correctly, and that the installer is identified, and that preferably that there's a photographic log of these things going into place. And we've got our little diagram here of where they go. So also with things like fire collars, that fire collars must, the fire collar installer's got to ensure that they're put in correctly and that the installer's identified and that there's a photographic log of that occurring. One other important thing then is on-site fire protection, and that's during construction. Because you will get, on a construction site, you'll get people welding or doing hot gas work, and in a normal concrete construction, they don't care. You know, it's fine. Sparks doesn't matter. But in a timber one, the consequences of poor management of this sort of thing can be quite significant, especially before the sprinkler systems are plugged in. So there is various approaches in terms of commissioning various stages of sprinklers as work progresses. and the NCC does have specific requirements, but it is something that needs to be taken care of. There has been 1 or 2 major fires in timber construction sites in other countries. That there isn't substitution of non-compliant materials with, of compliant materials with non-compliant ones. So it's pretty easy with some of the timber components to know that, you know, that's obviously this thickness, that's obviously plywood or whatever. However, with insulation products, there is a long history of substitution. There's a long history of non-compliant stuff being used, and once it's out of the packet, it can look pretty similar. So it's very important that there be no unauthorised on-site product substitution. And then with inspection, there's that during inspection, all the relevant fire grade products are inspected. They've confirmed that they've matched the specification and that they've been installed properly. That all the cavity barriers are installed and they're all being confirmed as being installed, and with the fire protection linings are all in place without unauthorised breaches. So just in summary, then the project team needs to ensure that there's a clear understanding and an implementation approaches to getting all the fire protection systems in place. So then the mid-rise timber project, there needs awareness, appreciation and action for in each of the stages to make sure that the end product is doing exactly what you want. And over time, then we're looking to build the expertise base of both the designers, the material providers and the builders so that they can do these things in a much more efficient manner. It took some time for multi-res construction, the 2 or 3 stories, to be more widely adopted and people to understand how you could do it. And this will also take some time for people to build the skill levels up. As designers and project leaders, then you can take a range of steps to make sure that it becomes easier for those people further down the line by, in the first projects, being particularly dogmatic. So I think that's a reasonable approach. Dogmatic first and then ease up later when people are confident in what needs to happen. So now there are 20 modules of videos on this. So all the points I've covered are covered ad nauseum in here. On lift shafts, isolated stairways, passageways, that key points section is all available then on video. They've all been loaded up onto the Wood Solutions campus, and there's now certificates been activated, and people can go in there and pick up 2 to, I think, 2.5 points all up, or 1.5 points just for an introductory section. So it's been broken into 3 sections, which have different points depending upon their length. There is assessments tied to each one, and you can do them at any time. Well, look, I'd like to thank you for coming, and if you feel like a chocolate biggie on the way out, just pocket one. Thank you. Good night.